Welcome everyone. I'm really excited because I made it. I could connect my new MacBook Pro M3 Max with Sonoma, the latest revision of the Apple operating system, by means of either the Sonnet Adapter for AVB compliant chip or with the double dongle, this little guy. So both are using this guy here. The connection of the USB-C Thunderbolt to Ethernet is working great. Or I can also use the Sonnet adapter. So the demo or the tutorial will be done with one of the two, but the steps that you need to go through are exactly the same. So let's connect my Sonnet adapter to my USB-C, connect the Ethernet cable. And of course, the connection is reaching a Lumix switch, which is creating the AVB environment. And from the Lumix switch, I'm reaching the Milan I/O inside of the Prodigy MP. So step by step, first of all, let's try to configure what is needed on the Prodigy side and on the Milan I/O side. So let's open Globcon. Discovering the Ethernet devices, I can find both my Prodigy MP, the Milan I/O. I add them all and I create the Globcon controller. So if I now go to the Prodigy MP, I need to make sure that the synchronizations are the ones that I want. At the moment, the Prodigy MP is generating internally the clock reference, which is one of the options, but I would like to have the Prodigy MP Milan I/O card being the clock master of everything. So I set the module as a media clock master, and therefore in the Prodigy, I have to let the Milan I/O card have the chance to become the clock master for the Prodigy. And then you can see that the automatic detection detects a valid 2FS coming in, and therefore I'm running at 96 kilohertz. This demo and this tutorial is based on 96 kilohertz operation, but as you can understand, nothing would change just the sample rate of the examples that we are going to do. So far, so good from the Prodigy point of view. Let's focus a little bit our attention here. You can see that I was previously having, during the test, subscribed, streams which are no longer available because I wanted to start from the scratch. So there's nothing set. The GPTP decision that I took, I left the owner and the duty to the switch to become the GPTP grandmaster. So I'm connected through the NIC number 2. So I'm just basically using one of the two options I'm having. At that point, primary or secondary doesn't really exist. It's either one. I'm just connected to the second one. Um, it's just a choice. And here, therefore, I select both for the primary and secondary the information to the Milan I/O card, not to become GPTP grandmaster, but to leave someone else, in this case, the switch, the duty of being the GPTP grandmaster. It is connected. The grandmaster ID, so the grandmaster identity has been detected. And guess what? This is the MAC, address of the Lumix device. Fine. Now, let's minimize Globcon for the time being and focus on what we have to do on the Mac side. The first thing that we have to do is to open the AVB controller. The AVB controller, if it's the new computer, if it's the first time that you are opening, is not available among the several icons. So you have to open the terminal, don't worry, you will do it once, and then you have to type AVB util. Let me get it bigger. AVB util space dash dash controller, and then you press return. And then all of a sudden, the AVB configuration is turning up. A trick and a hint that I'm suggesting, since the AVB icon is then available, please, to avoid that next time you have to reopen the terminal, get that icon among, and then I will usually put it just beside the audio and video, audio and MIDI setup. You will see that when you open the audio devices, there's no mention of Sonnet or other AVB gear. Why? because it is true that we opened the AVB controller, but so far we did not activate the built-in virtual audio entity. And this is the next important step that you have to go through. So when you activate that, please make your life simple and configure the device that you want to use. If you want to operate in a Milan environment, despite the fact that the Mac is not Milan certified, it will perfectly work if you decide which is the audio format which is actually supported by Milan. So instead of making your life complicated, just leave the integer AVTP audio format for the streams. And by the time that you have clear ideas about which is the sample rate that you want to use, just leave the sample rate that is, of your interest. In this case, we are simulating a 96 kilohertz environment, and therefore, then you have to decide a channel per stream. If you want to get all the 64 audio channels out of your computer and reaching the 64 channel capabilities at 96 kilohertz of the Milan IO, you need 8 channel per stream, but you also need 8 channels. So don't click here because then it's not, confirmed. So tab that. Now it's 8.8, and you create your virtual entity. You don't need to change the configuration per stream, so they are all equal, and then you get there. So you might expect that since you have enabled the virtual audio device, it should logically appear among the options. Don't be scared. Don't worry. No panic. It will show up. The reason why it is not showing up is because for the time being, there's not a single output stream created and connected to a receiving device, and therefore there are no output actually available. The same for the input. So what you have to do now is to open Hive that you need to have previously download and installed, and you will see that the MacBook Pro and the Milan IO will be discovered. Now you can see that in the Milan IO, you can try to send one stream, and then that is enough for you to, that's the magic. All of a sudden, there's a new audio device inside of your Mac, which is able to exchange with core audio drivers, input and output. Just because that device has been actually activated, just having one of the stream working. So now here, you don't need to go through the AVB configuration any longer, because in the latest revision, they moved everything here, which is much more user-friendly. So for the time being, the clock source of your AVB virtual device is your Mac's system clock. And that could be a little bit of an issue because we decided in the Prodigy Milan IO that we wanted to have the Milan IO card as a clock master. So we have now the possibility to say, since you have subscribed something like this, so you are getting an audio stream from the Prodigy Milan IO to the MacBook Pro, you might want to change that configuration and select the clock source of the device from the first incoming input stream. Careful, if you do not confirm the clock domain, clock source change request, the settings that you have changed is not really happening. So you have to allow that, and then you have the Mac virtual audio driver, which is expecting to receive a media clock information from the first incoming input stream. And I'm glad that the problem appeared, because you see there's something missing here. So theoretically, Hive tells you that the MacBook Pro accepted, but actually for some reason the media didn't get through, and therefore there's no this, there's a kind of let me open this kind of symbol is missing here, which means that it seems that apparently the AVB Milan didn't accept that. If we can double check here, we actually have the confirmation that that link or that subscription didn't really get through, and therefore you have the confirmation that the output stream of the Prodigy has actually not been subscribed correctly from the device. So my experience says that if you try 2 or 3 times and there you go, it is now working. It is confirmed by the Hive, which is showing the uh, purple triangle or whatever, and it's confirmed also by the fact that now the Milan IO got the acknowledgement by the listener that the subscription is happening. Now we are completely synchronous because the AVB device accepted the clock from the incoming input stream, and therefore the Milan IO is the clock master, and that is also confirmed by Hive. Hive is telling you that the media clock master is self for the Prodigy MP Milan IO, which is deciding how long is a second. And then by means of the subscription of the first AVB Milan output stream of the Prodigy MP from the MacBook Pro, the MacBook Pro is extracting that information from the audio input stream, and therefore our devices are all synchronized. Remember that also the Prodigy MP is getting the information of how long is a second, and a base rate of 47999.53, and then it multiplies by 2 factor frequency scale in order to operate correctly at 96 kilohertz. So the entire chain here is completely synchronous. The real media clock master is the Milan IO, which is sending clock information to the Prodigy with the internal connection and towards the Mac AVB virtual driver by means of a normal audio stream. So we are now ready to run one, let's say, any kind of DAW, just to see if we can really send audio. Let's open the settings and select among the available one of the virtual audio driver. In my previous attempt, I was using the Thunderbolt Ethernet. I told you that it is working correctly. So Reaper is remembering the last device which was connected to. That device is not any longer available because it's not currently connected, but there's the one going through the Sonnet adapter, and it shows up with the name of the chipset, which is Broadcom Net Extreme Gigabit Ethernet Controller. If you say that, and if you apply that, and if you press OK, you are already in the position to say, okay, let's loop that and play. You have already a very good news, because if the DAW is actually playing and is not complaining, it means that the core audio driver underneath is really accepting the wave file and the audio information coming from the unit. So now let's go back here and see if we are receiving something. It's impossible that we are receiving something because we didn't make the routing. Therefore, the AVB Milan stack of the Milan IO is still waiting for the old ones, which are probably not even available in the network. So we go to Hive, we open the Prodigy as a receiver, as a listener, and you see that there's an indication that the old subscriptions are not available. I'm opening the MacBook Pro and I'm trying to read the thing. Way magic. There you go. I have all my 64 channels. It seems that channel 32 and 64 are not there, but actually I'm playing the BLDS for an example that I want to do it later on for the ears. So we are good. And then if we try to keep the visualization within the same monitor, so let's try to do this, get rid of that, put it here and reduce a little bit here so we can see in real time what I am doing. If I am removing one by one, you see that I can remove a single stream of 8 channel each, and that is confirmed. Okay, so everything went very smooth. Once you know what you have to do, it's not going to be a problem. There are several things which made me a little bit crazy. And now I know while, testing what I was doing wrong. And I want to inform you about a few things that you need to understand. Let's proceed with order. First of all, I was fooled by the fact that the description of the audio format is a little bit different from the Mac side or the Hive and Directout Milan I/O. Don't worry about the fact that you are selecting 8 channels of 24-bit integer. The most important thing is that integer is the selection. The 24-bit coding is the real audio coding PCM, but then the transmission is happening in 32 bits. That's the reason why if you open Hive and if you get to the device detail and you get to the stream format, you see that the input and output stream format of the Mac are represented at PCM integer 32. 32 is the length of the transmission of the data, has nothing to do with the 24-bit coding. So this is exactly the same information that you are having here. So there's a discrepancy between the representation, but it's just the way that the streams are described. Here they are named on the Mac world 8-channel 24-bit integer, opposed to 32 floating. You don't want to use floating. We decided not to complicate our life, and therefore we removed that option when we created the AVB virtual unit, and therefore the right one are the PCM integer, which is described as 32 because from Hive and from the Milan world, we are just transmitting 32 bits inside of the Ethernet streams. And the most important thing is that is AAF 96 kilohertz, which is the selection that we took when we created the virtual audio device. So that's clear. That's not a problem any longer. The other thing which might create problems to you is that when the AVB virtual device is not having a valid clock reference, is producing anyway the AVB stream, but that stream cannot be locked properly in terms of media from the listener. So it's easy to simulate that. If we leave the audio input stream as a clock reference, as a media clock reference, and if we remove the patch point between the output of the Prodigy, you see that not only the device is in trouble, but it's also disappearing. And the net effect on the Hive is that you have the indication that the streams are subscribed, but the media is not locked. So if you open the color coding, you see that that is the information connected, but not media locked. And that is also confirmed by a clear error message on the receiving side of the Milan I/O card. As soon as you fix the problem, and I want to fix it in a different way. So I need, first of all, to recreate the condition to see my device here. Otherwise, I cannot even change the situation. So in order to reestablish a situation, I'm simply sending again a valid clock reference out of the Milan I/O and get into the MacBook Pro. Now you see that the stream is back and everything is magically back. Well, not actually, because the stream apparently is subscribed, but you can see that that is not happening. That's another thing that you have to be careful. Don't trust this bullet point without the purple arrow, because that is not, working. But no problem for the time being. As long as you have something, even if it's not really locking, at least you have the options here. So I want to show you that even if the media clock is not in sync, meaning that I can go back to my system clock. Remember that you have to confirm the change here. Now my AVB virtual audio device inside of my Mac is in free run, mean that is generating its own clock from the Mac system clock. Nevertheless, that is enough to create a connected media, it's clear that in this case, and Hive is confirming that, you are not having a synchronous situation, and therefore the two devices are both independent in terms of clock, but the audio is getting through. You will simply have the same side effect of glitches or noise from time to time as you would have in case of a MADI connected in asynchronous way or with an AES which is not properly locking on the input side. So I just want to tell you that this is not, of course, a working condition because you would need a sample rate converter available inside of the receiving of the Milan IO card or any other, which is probably not easy to achieve. So you need to fix the problem. How can we fix the problem? We can reverse the duty here. So we can say to the Milan IO card, you know what? You cannot be the clock master, so get the clock information from the stream and get the clock information from the stream number one. So the stream number one is now bringing the media clock information coming from the Mac. So the Mac became my clock master because then from the Milan IO to the Prodigy, nothing has changed. And therefore, the Prodigy is not even aware about the fact that the information of how long is a second, the media clock, is coming in any case from the Milan IO, and then he's not aware if the Milan IO is the real one generating that information or if also the Milan IO is getting that information from an external device by means of an AVB stream. So in this case, we are in a working condition anyway, so we can go back to our DAW. Don't expect that the DAW was happy about the fact that there was a kind of an earthquake. So most of the time, if you go to the Reaper settings or other settings, all the audio devices disappeared. So you just have to restart your DAW, as you know, many times is happening in this case. The audio engine underneath has been rebuilt, and therefore if you go to the settings you see that your audio device is back there, and then you can start playing audio again. If I go back here, I have all my audio output, and my audio is perfectly working in synchronous way because now the clock master is the AVB device. Okay, so this is what I found out. Now, I want to go back to the original situation, and I want to make sure that the clock master is actually the Prodigy MP, because in case I want to use more than one rig, more than one Mac rig to have A and B for my redundant playback rig, it's not a good idea to let one of the two computers be the clock master, because in case of the switch would have been needed, also the work clock master would change, creating a not, seamless, transition between main and backup. So in such an environment where the Prodigy MP is the one supposed to do the years, the enhanced automatic redundancy switching, is a much better idea to let the Prodigy or the Milan IO inside of the Prodigy be the clock master. So we need to make sure that the clock is accepted, and we just have to try and try until we have the confirmation that the settings has been accepted. So now we can go back to our audio settings and set back the clock from the audio input stream number one. Remember, you always have to confirm the change, otherwise it's not really happening. Now, we are in the situation that since we didn't change so far the situation here, where we are still waiting for the NIC, you see that there's an issue. It's an unstable situation. Why? Well, Hive is helping us to understand why, because we put ourselves in a loop, in a recursive thing. Prodigy is waiting for a media clock from the MacBook Pro. The MacBook Pro is waiting for the media clock from the Prodigy. I'm waiting you, you are waiting me, and therefore nobody is really informing the others, and therefore we are in a stuck situation. And in this case, it's also confirmed that the media cannot be locked because there's no locking possibilities. So it's easy to change the situation, go back to the Milan IO and say, go back to the original idea, and the module is the clock master, give a few seconds the system to get, you know, stabilized on the new media clock master, and everything is okay. And you will see that Hive is confirming that now all the media are locked. And probably your DAW didn't suffer too much, and it is still working. So if you open your audio is perfect. So now we are in the situation that we are receiving 64 channel in 8 channel stream with 8 streams. And then of course, we could simulate that those streams were coming from 2 different Mac. Well, now I don't have a second Mac here to make the real test, but let's imagine that the first 32 channel are coming from the first Mac, the second chunk of 32 channel are coming from the second Mac. And therefore, I can simulate the entire thing with just a 64 channel track. So I put the BLDS for the main on track number 32 and the BLDS of the backup unit on channel 64. How? Well, it's easy. Just open the routing matrix, and then you see that I put the channels of the BLDS main leaving my interface on channel 32 for the main, and I put the audio of the BLDS backup on channel 64. So when I'm simulating the BLDS main and backup, of course, I need to keep muted the channel, the relevant channel, which is used, not usable for playback tracks, but just for the trigger signal, which is the BLDS most of the time, if you can stay synchronous, or pilot tone, worst case scenario. So on channel 32, I'm muting the audio because on channel 32, we'll leave the BLDS main. And on channel 64, I muted audio because I want to send the BLDS backup. So if I'm having a straight connection, I should receive on the Prodigy side those channels. So if I go to the input, I go to Milan IO, I can see this little, very low level signal, which is my BLDS. Let's see if it's true. So let's minimize thing and then mute the BLDS main. If I go back here, my BLDS disappeared. So it's true that the BLDS is arriving on channel 32. Re-enable that. Channel 32 is now enabled again. Perfect. Channel 64, network number 3364. We have the channel 64 here, which is producing audio. Not a good idea. So 64 should be muted. Now, therefore, you only have the BLDS. Double check muting the channel 64. The BLDS on the second chunk would disappear. So we have everything we need to simulate the crash of the main system. We go to the setting, we go to the ears, and we activate ears on net 1A, which is our first chunk of the Milan IO, 32 channels at 96 kilohertz. The second portion is used as a backup, and therefore we are receiving the BLDS on channel 32, the BLDS on channel 64. If we decide that we have the priority on main, we can simulate the entire thing just listening to the first 2 channels. So now we are selecting channel 1 and 2 if everything goes in the right direction and main is okay, and selecting the replacement of channel 1 and 2, which are channel 33 and 34, in case the BLDS of the main rig should fail. How can you listen to that? We go to the home, we go to the monitor, and we put ourselves on channel number 1 and 2.
I see trees.
You can see it better here. If I mute
that are green, it can't be so. We were right till we weren't. For me and you, and
I think that I went through all the settings. I'm very happy to tell you that it is working really, really reliably. And then next time, you don't even have to open the terminal. Next time, if you don't change your configuration, your AVB virtual device, if you connect exactly the same Ethernet adapter and you leave everything untouched, will be exactly as you left it last time, including the patching between the computer and the Milan IO. So it's really, really nice, and the latency is fantastically low. Oh, I was forgetting about an important thing that I didn't mention. Don't worry about this little red dot that you have inside of the cross point. Thanks God I remembered about that. So what that means, it means that if you open the color coding, that connect but MSRP latency exceeds presentation time. MSRP is multiple stream reservation protocol, which means that the AVB environment is making sure that once the stream is available, it doesn't suffer from the fact that other devices are consuming bandwidth inside of the unit. The reason why you have such a warning is because the presentation time of the Mac, if you look at the device identity and you look at the latency, is fixed to 0.025 millisecond. And even if you try to change it, you're not going to make it, which means that the default AVB settings of the Mac are fixed to 0.25 milliseconds, while the typical latency of devices which are Milan certified or Milan compliant are set to 2 milliseconds. So the Milan IO knows that it should not be different from 2 milliseconds, but actually, since it is decided by the talker, the AVB virtual device of my Mac in this case should be 0.25 milliseconds to 250 microseconds. It's clear that he doesn't have the time to play as for the wish of the talker. But that's not really a problem. We are simply playing that late, but late compared to the timing that the talker, so in this case the computer, would have desired. But we don't care. We know that the total latency will be 2 milliseconds instead of 0.25. So that's the reason why you have such a warning, but that is not at all impacting the audio quality. You are simply playing that with 2 milliseconds of overall latency instead of the desired 0.25 of the settings in the Mac. So don't worry about that. This is absolutely to be expected. And then as long as we will not find a way to change that information inside of the Mac, we will simply ignore and we can live with that, no problem at all. So 2 milliseconds of overall latency from your Mac to the receiving playback device is more than enough. Thank you so much. I hope you enjoyed this video tutorial and I wish you a good day.